This Zoom session is being brought to you by the Fractal Hex Bullseye Horizon. Well, now that we're over the edge of the cliff, uh, I'd like to go over, okay, some more extra credit sets, such as this Pythagorean triples. Let's look over this. Right. A Pythagorean triple is a set of three whole numbers, integers, such a squared plus b squared equals c squared. One of the classics is the 3, 4, 5 triangle. 3 squared plus 4 squared equals 5 squared. In fact, I'm given to understand that they actually found a loop of string around near the pyramids in Giza, where there are 12 loops. There was a loop of string with 12 knots arranged at even intervals, because that way you could stretch them into a 3, 4, 5 triangle and thus make a very poor man's right angle. Whatever. There's a 5, 12, 13. A number of others. Now here's the claim. If you have two whole numbers, m and n, then m squared minus n squared, 2mn, and m squared plus n squared forms a Pythagorean triple. Therefore, this would be a right triangle with one side m squared minus n squared, one side 2mn, and the third side m squared plus n squared. And okay, so for example, you said m and n equal to 2 and 1, then you get the 3, 4, 5 triangle. You said m and n equals 3 and 2, you get the 5, 12, 13 triangle, and there are an even number of others. Here, if you try m and n be 4 and 2, you get a 12, 16, 20 triangle, but that's really similar to the 3, 4, 5 triangle. They're just bigger by a factor of 4. So in a certain sense, these aren't that really different. Now, okay, for one extra credit point, prove this identity. It's a matter of expanding the square of m squared minus n squared, expanding the square of m squared plus m squared, squaring 2mn, and proving that this plus this in fact equals that. It's a relatively routine bit of algebraic proof. Start this, simplify it to something, start from this, simplify it to something, and if they're the same thing, then you're done. And then, okay, so use the question here, section here is to use this to form 4 Pythagorean triples that are not similar to the 3, 4, 5, or the 5, 12, 13, or each other. So I don't want any reruns of any of these, even in multiples. So and this matter is simple. You just have m and n be different things. It's a good idea to have one of them be odd and the other be even. Otherwise, there's some redundancy there. And that should do it. So this is worth 5 points for you. Let's see. Here is a, excuse me. Here, these super hexagons. This is something I saw online a while back, and I found a cute enough mnemonic for various relations between the trig functions. Here it is: tan, sine, cosine, cotangent, cosecant, secant, and 1. The idea is that those that are on opposite sides, tan and cotangent, sine and cosecant, cosecant and cosine and secant, those are reciprocals of each other. So that 1 over tangent is cotangent, 1 over sine is cosecant, 1 over cosine is secant, and vice versa. Another one is that if you have 3 in a row like this, this, and 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 this, and the first 2 multiply. Oh, the ratio of the first 2 is the third, so sine over cosine. Do I have that right? Oh, I'm sorry. Cosine over sine is cotangent. Let's see how they AC equals B. Sine times cotangent equals cosine. Cosine times cosecant equals cotangent. Cotangent times secant is cosecant. Cosecant times tangent is secant, and secant times sine is tangent. So if you have a bent 3, then the product of the 2 around of these 2 equals the middle. This times this equals this times this equals this, and so on. Therefore, from that, you can also get various ratio identities. So sine over cosine is tangent. Cosine over cotangent is sine. Cotangent over cosecant is cosine. Cosecant over secant is cotangent. Secant over tangent is cosecant. And tangent over sine is secant, whatever. So we have these. There's also some complementarity relations. visible on the superhexagon. So if you flip through this vertical diagonal, then you get complementary functions, sine and cosine. So sine of 90 degrees minus theta is cosine of theta. Tangent of 90 degrees minus theta is cotangent. Secant of 90 degrees minus theta is cosecant theta. So complementarity relation. Then with these three triangles, this, and this, you get a Pythagorean relation. So with this, sine squared plus cos squared equals 1. 1 squared plus cotangent squared is cosecant squared. Tan squared plus 1 squared equals secant squared. This is a mildly useful way of remembering certain these. I'm never be sure if it's tan squared plus 1 is sec squared or sec squared plus 1 is tan squared. You have to remember it. So okay, so this is a way of remembering these things. Minor visible thing. Okay, well, we haven't much to do today. We have much to do for the rest of the semester, except I suppose me to ask you questions about what you want to know on the homework, quizzes, and final. But let's see. Tell you what, I'm going to go over one more thing. These antenna. This is a problem set. I call it antenna on a roof. Here's the idea. Here's a building with height B. At the top front is this antenna of height H, which you want to find. We know how tall the building is. You know how far you are. This is your eye looking at it. So this is how tall the building is, how far you are from it. There's this angle beta, whose tangent is B over C. And then there's the angle alpha, which the antenna subtends. So you know how high the building is. You know how far away you are from the base of the building. You know how big an angle the antenna subtends. How long is the antenna? Okay, well, there's a couple things you know. B over C is tangent beta. And tangent of alpha plus beta is H plus B over C. Therefore, H plus B over C minus B over C equals tan of the sum minus tan of beta. This simplifies down to H over C. Well, we don't know H, but we do know C. And then this tangent of a sum is tangent plus tangent over 1 minus tangent tangent. That minus tan beta. And this is B over C. This is B over C. This is B over C. You do some algebra, jinga, 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 jinga. Here we go. H is C squared plus B squared sine alpha over C cosine alpha minus B sine alpha. There's a formula. And that applies to this. Given alpha, B, and C, you're going to get H. So using that formula, you then can solve various versions of this problem. So various values of alpha, B, and C, find H, and that's an extra credit set worth 4 points. I'll go over more things later days. Here's this. This will discuss the when you have a combination of cosine and sine. This term, you can find that equals a multiple of cosine of a sine somewhat phase shifted. I'll get to that later times. And here we have various things about inverse trig. This is a supplement to the problem sets in the homework, the book about inverse trig. This is a stereo vision problem. This is the height of a tree problem. These 5, is it 6? These 6 are a different way to approach the side-side angle problem. Given a side, and an angle, then what is the two angles and what's the third side? And before we've done it by a law of sines, there's a way which is equivalent to the law of cosines. Then here's something called tangential addition, which again, I'll wait for later. Well, okay, I do feel a little embarrassed having finished the book earlier than the course. I hope you managed to keep up. Let me take a look at your homeworks. Excuse me. Yeah. Well, a fair number of you have gotten all the way down to doing the final. One of you. A lot of the rest of you have gone at least as far as quiz 2. Some of you have done chapter 5 as well. And well, there's Orion, Murray, I want chapter 2 and quiz 1 from you. There's some others. Most of the rest of you are really solid. Brenda, Harrow, Spizka.
I'll have it to you by the end of the weekend. I'm actually doing the final right now.
Do what you will. Yeah. Harris,
thank you very much.
Yeah, no problem. Harris Rahid, quiz 2 from you, and chapter 5 and final. Let's see. Yeah. So Mariah Murray, chapter 2, quiz 1, quiz 2, and then most of you, some of you have done chapter 5, the rest of you, chapter 5, and then there's the final, and that'll be doing it. The work for the semester. Well, okay, I'm here for questions. Questions about the homework, the final, the this, the that.
Wasn't it all due? I didn't get the due date last week.
Pretty flexible, within the month, okay?
Okay. Got it.
Well, okay, if you have questions, this is the time to ask. If not, it's time to call. I see you have questions. Yes?
I have a question on the homework set, chapter 5, 6, number 58.
Momentarily, I'm turning away. 5, 6, 58.
When I did that one, the answer I was getting called for the cosine of the number I was getting, but the number I was getting was greater than 1, so it was outside the bounds of.
Right. 5, 6, number 58.
Yeah.
V equals 3 by negative 4 by 1. W is 6 by negative 8 by 2, right?
I believe so. I'm just cranking it open right now.
Yeah.
Should have had it open.
5, 6. Let me double check myself. Right. And so they want to find the dot product and the angle between them, right?
Mm-hmm. Yes.
Okay, you know the dot product. It's either 3 negative 4 by 1, 6 negative 8 by 2. So you have to multiply 3 times 6 plus negative 4 times negative 8 plus 1 times 2. And that's the dot product. Once you get a number. And the angle, cos theta, let me see if I can review it. It's around in here somewhere. Let's take a look. Angle is, oh no, that's cross product. My apologies. 5, 6. Here we go. Cosine will be theta will be arc cosine of the dot product of the product of the lengths. See if I got that right. There we go. Yeah, dot product over product of the lengths. So theta is arc cosine of v dot w over length of v times length of w. So you need to find the length of 3 by negative 4 by 1, length of 6 by negative 8 by 2, multiply those lengths, divide them into the dot product, and find the arc cosine. And yeah, it shouldn't be bigger than 1.
Yeah, I'll have to go back and redo it because somehow I came up with 3.39. I'm trying to take the arc cosine of that. Obviously, it's not working.
Not working. Well, okay. There may have been some sign things running around. 3 or 1, 6 negative 8 2. Sometimes a negative number can, and also maybe that 1 got lost or stuff like that. Almost certainly clerical errors. That's what most of my students' errors are. But that's the math of it. It should work out reasonably well. Okay.
Thank you.
Sure, no problem. Good luck. More questions? Mr. Hernandez, you look puzzled.
Oh, no, no questions.
Okay, no questions. Well, all right. Well, I'll be sitting here. And if you have questions, etc., please ask. Otherwise, motion to adjourn. Is it seconded? It has just been seconded
Second.
It is
Seconded.
seconded.
and thirded. Okay, great. Well, I'll be here for a little while. And
Thank you very much.
all
Thank you
right.
very much.
I'll
Thank
be
you, sir.
here, and I'll be here on Tuesday, on Monday and Tuesday, on Monday and 1 to 2, and in the evening. So
I'll have that quiz to you as soon as possible. Thank you again.
no problem.
Thank you. Good night.
Take care.
Thank you.
Oh, that was so easy. All right, Matt. Deal with this. I'll stop here. Yes, share screen, Nathaniel. That's what you want. Oh, that's right.